Hello, everyone. I hope you've had a great week so far, and I hope you're having a good morning or afternoon wherever you are. So, welcome to the fifth installment of the Unravel Optimize webinar series. I'm Sarah, and today we're joined by Patrick Mawyer, Senior Solutions Engineer here at Unravel. And today he'll be discussing troubleshooting Databricks. So before we start, there's just a couple of quick housekeeping rules as usual. So if you have any questions, you can feel free to pop them into the questions box and we'll answer them live. Or if we happen to run out of time, we'll send them as an email reply. The webinar will be available instantly on demand. So if you have to drop off for any reason, you can feel free to come back to the same page, the same link, and listen whenever you have the time. And also let us know what you think about this session by rating the webinar and let us know if there's any other topics you'd like to hear about. So now that those are out the way, you can take it away, Patrick.
Thanks, Sarah. All right, so let me go ahead and bring this up on the screen. This is, as Sarah mentioned, the Troubleshooting Databricks is part of the Optimize series, webinar series for Unravel. So as mentioned here, what we're going to be doing is talking about troubleshooting Databricks. A little bit about
Hi, Patrick. We can't hear you, actually. One second, guys. We're going to get this audio issue figured out. Sorry, guys. Just give us a couple seconds, a minute. We're trying to figure this out.
Are you able to hear me?
Yeah, I can hear you now.
Interesting. Okay. Yeah, something is going on here with my peripherals. Let me know again if I drop from audio.
Okay.
Set up. Okay. Sorry about that, everyone. Yeah, so just we'll circle back. We're talking about troubleshooting Databricks. My name is Patrick Mawyer. I am a senior solutions engineer here with Unravel Data. You'll see my email there on the screen, pmoyer@unraveldata.com. I'm also available on LinkedIn, so you can find me there as well. So we're going to start off, before we jump into Unravel, let's talk a little bit first about the life of a Databricks developer. So when you're developing your applications, you're running them in your interactive or your job clusters, a lot of things can happen and stuff will come up and you want to know, why did your job fail or why is it maybe just running slow? Did you configure it properly? What type of configuration changes can you make? When you set up your job cluster, did you choose a correct driver and worker instance type for that cluster? Should you use auto scaling with your jobs? And other things that could come up that maybe isn't necessarily Databricks, but there are problems potentially with the cloud services underlying your clusters and understanding that from an infrastructure perspective. So today, how would you go in and troubleshoot what's going on in Databricks? You have to consider things like the structure of your cluster. So again, the number of nodes that you have, what are the resources available in those nodes? Your Spark application execution. So we're talking about the actual execution of the code. How is that running? How is it dealing with the data? Which is the third point, data. How much data are we bringing into our application when we process? How is that being shuffled and cached as we are running our applications that could be impacting the performance of our jobs? And then there's cluster workload context. So if you're running in a shared cluster, you may have jobs that are running at the same time that could potentially be impacting the execution of your application in that cluster. So understanding what else is going on in your Databricks clusters that could be impacting your own applications. So to do that troubleshooting today, there are common tools available to you from Databricks. There's a Databricks UI that's going to provide you things such as cluster information. What are your all-purpose clusters or those interactive clusters, job clusters that are automated to run when you're running particular jobs. So that'll give you the cluster level. We also can then from the Databricks UI go and see what jobs we have and what executions of those jobs have occurred, and see some of the things such as how they were launched, how long did they run for, and if we wanted to drill in and look at details, we could do that. And that's going to start taking us into some other tools that are made available to you, such as Spark UI. And Spark UI is going to give you some information that allows you to see, again, what were the jobs in my Spark application that executed, how long did they take to run, how many stages made up each of those jobs. At the stage level, if I drill into that, I can see, the number of tasks that were related to that stage and what the stage was executing and a little bit of data information. So you get some pretty good information here from Spark UI to sort of give you some data points that you can use to then make some determination on what maybe is going wrong with your job or how to potentially optimize it. There's also the executors aspect in Spark UI. So if I want to see the drivers and executors that had, run as part of my application execution and what they were doing individually as far as resource utilization and the data usage, you'll get a little bit of that information here in Spark UI as well. Then you have the other component outside of Spark UI is going to be the Spark logs. So we want to look at the logs from our drivers and our executors related to our jobs. So as you can see here, you can get to those various log files, have that data presented to you in the Databricks interface. So again, more data points to feed you to help you then go and troubleshoot and try to figure out what is going on with your jobs. The infrastructure side of the house, this is where Ganglia comes into play. So Ganglia packages with Databricks. It's going to give you a few things that you can look at more from your infrastructure metrics. So we look at cluster level metrics. We can also then drill down and look at the individual node within our cluster. Now keep in mind, this is a different interface than what we talked about with Spark UI and looking at the logs. This is just a general view that we are looking at in Ganglia related to our cluster and our other hardware. There's no job context here. And then the last part, a lot of times we talk about, actual software tools that we use to help, but we can't overlook resident experts, right? We have other Spark developers that can help us troubleshoot, that can give us some insights on what we can do to improve things. We also have our infrastructure engineers, the platform engineers. They have that infrastructure level insight and maybe some insights into what's going on beneath your running application to help you troubleshoot. But at the end of the day, the resident experts are probably the most costly of everyone. They're human resources. They're typically highly skilled, and for them to help and troubleshoot on thousands of jobs potentially running throughout the day is very taxing on the organization. So we take all of those components together, and what does that provide for us? So with the Databricks, Spark UI, and logs, we're looking at high-level status metrics of our jobs, analyzing the code, so looking at that Spark context, tracing those logs relative to jobs, And it's, it's part of the platform, so it's not like you have to go and install anything. And then from the infrastructure side, to look at network metrics and host level metrics, we're going to have Ganglia. And then the third component here that then gives us code level insights, optimizations, configuration level stuff. Those are resident experts. Okay. So we've covered all of these boxes here in these three columns. If we add Unravel into the mix, well, Unravel can give you a single point to get all of the information you need around your job, the code, the infrastructure, and with an AI built into our platform, you essentially have those resident experts in a box. You free them up to go back and do the other value add activities that they are on the payroll to do. And now I don't have to worry about, as a developer, jumping between Ganglia, Spark UI, the Spark logs, and trying to then piece that all together to see a holistic view of what my job was doing in the cluster. So with that, I'm going to jump into the demo, and we're going to be able to see then what Unravel looks like and how we get access to that data in that single pane of glass.
Just give us 1 second. Just pulling up the demo, I'm pretty sure. One second, guys. I'm going to get in contact with Patrick and see what's going on. Sorry about this. Patrick just having some laptop issues suddenly. He should be back shortly. Sorry about this again.
Hey, Sarah, can you hear me?
Yeah, I can hear you.
Yep, sorry. My computer decided it did not want to cooperate.
It happened.
All right. So, Unravel platform. What you see here on the screen, this is Unravel. We're looking at the cluster tab. So when we think about platform engineers and sort of what they want to look at over the course of time, this is a view that's going to give them some insights into the node level resources that are available across all of the clusters in your environment. The things that I like to highlight here, and this will also help in the troubleshooting aspect, or at least being proactive in understanding if things are starting to go wrong. We look at inefficient events. So all of our Spark applications that we have running across our clusters, as we're detecting events, we're surfacing that here. So you see over time, if we're starting to maybe bring more inefficient apps into the organization, that's going to show up in this graph, and we quickly be able to then drill in and figure out what's going on. The other thing too, when we talk about understanding what's going on holistically in the cluster, if I want to go and look at the cluster level resources and break those down different ways, so we can talk about the general vCore and memory that's available across all of our clusters. But if I want to understand what vCore memory usage looks like by various users or by departments or different workspaces, we can do that here in this view. And if I wanted to look at a particular point in time and highlight that and see specifically what were the jobs that we're executing, I can come down here and see that by looking again at that point in time. I could even drill into these jobs from this angle if I'd like to. I'm not going to do that for now, but that would be an option that you have. Just keep in mind as well, you get to see DBU usage and cost over here per job. So that's something that really lends well from a cost perspective, not necessarily what we're talking about today with troubleshooting Databricks, but if I get to the end, maybe we can talk about the chargeback and cost aspect a little bit. Usage trending. So again, like if we're starting to see a certain type of usage trend occurring across our clusters that might indicate overutilization, or maybe we're going to run out of resources if we're using static clusters, we'll be able to see that from this view. And then workload. So if I really want to understand throughout the days of the week, where is my heaviest usage? So maybe I'm encountering a problem where my users are complaining about jobs running slowly or failing because there's not enough resources allocated, and I want to see what's going on at that particular point in time. I can highlight into that and then see the specific jobs that were occurring at that point in time. And then this allow you to make some decisions on, when might be a better time to run these jobs. And that could even be from a cost perspective if you're using things such as spot instances. And spot instances maybe are not really available at certain points of the day because of a lot of people looking for spot instances. So you might be able to then sort of reallocate where you're running your workloads utilizing this method here. Now, talking about our inefficient or our failing jobs, we come here to our cloud clusters, and this is going to basically let us see all of the various job clusters that we've had running or interactive clusters and the jobs that run in those interactive clusters over a specific period of time. And this is, looking at right now we're looking at all jobs I've run over the last 90 days. I can look at the configurations for my clusters, or I can drill into the Spark context and see actually what was running in that cluster at the time. But very quickly, what we can highlight here is inefficient events. So with very little effort to understand where I'm having inefficiencies or failures that we can provide very quick insights on, I can come here to this inefficient tab. Very quickly, as I said, all this stuff is here. We can see insights are available for tuning suggestions for each of these jobs. If I wanted to grab low-hanging fruit and find events that are occurring on a significant number of jobs, and then figure out, let's go back and shore those up and improve, optimize our applications so that they run faster or fail less or what have you. I can do that from this view. So for example, I'm having executor imbalance issues. So let's go ahead and highlight those and see what jobs come up. Now, one important note here, right, is it's an event that's probably something we want to address. But if I just think about from the fact that my applications are succeeding, I may ignore this and just say, hey, everything's great. When in reality, there are definitely some gains that you can get from this. So let's go ahead and grab one of these. We'll drill in and see what we get for recommendations on this particular service. So in this case, we have a Spark streaming app. We can see the streaming that's occurring here. Our analysis tab. So this is the important aspect. We talked about all of that information that you get from Spark UI and the logs and Ganglia and my resident experts looking at all that and making decisions. These are those resident experts right here. We've gathered up all of the resources relative to my application, all in this one location, right? The resources that we have allocated across our drivers, executors, the logs, surfacing any errors that maybe have occurred in those logs, what was the configuration, all of this information available to you. And then our AI, that resident expert in a box, looks at all of that. And rather than you having to drill down into the data and piece things together and figure out where we can optimize or why did something fail, surface right here under this analysis tab. And as I mentioned, we're looking at a load imbalance issue on our executors, highlighted right here. So this is where we see there's a large variance in the work being done between two different executors, 5 minutes versus 0 minutes. Okay. Brought right to the front. Now you can very quickly go and address that problem in your code. We have cost instance recommendations. So this is where I talk about, some of the cost. We could call it cost troubleshooting, I suppose. Also comes in here as recommendations. So we can analyze how your job, or in this case, our Spark streaming app, is running and how it's utilizing resources. And can we make a recommendation on changing your driver or your worker type to save money? So, hey, right now we got a standard. It's pretty simple. It's probably the first thing you see when you set up your cluster is a 14 gig, 4-core standard box or VM. But based on what you actually need, you can get away with much less on the side of memory and still be able to run your jobs as effectively as you could with this larger memory. And we can do that for both our driver and our worker. Streaming performance trends. So obviously this is something more specific to Spark streaming versus more your standard app. But looking at these various performance indicators, we can see that our total delay on our processing is significantly less than what our micro batch interval is. So we can make a change to this micro batch interval and make our Spark streaming app faster, right? So being able to get to this information quickly through all of that hodgepodge of different monitoring services, so Ganglia, the Spark UI, etc. Being able to come up with these three answers that we've just highlighted could be an entire day worth of looking through data and trying to figure out where to make changes. And we just saw this provided to us in a matter of minutes. Now, some of the other things I mentioned here that we could look at, resources. So I want to see the number of tasks that ran for my job over time, number of containers that spun up or spun down, vCore usage and memory. So you'll be able to see that here as well. So if we're seeing, maybe our vCore memory allocations have taken a sudden dip, maybe one of our nodes has gone offline, we'll be able to see that quickly here, which would likely manifest in some other kind of issue that we would also see. But again, all of this information very quickly, I don't have to go through a lot of interfaces. That Ganglia aspect and understanding, various metrics around our JVMs and our host level metrics, all available to you here, broken down by drivers and executors. So again, we can see if we're having problems with a particular executor, maybe taking on too much of the workload, running out of memory, and then we have to go in and we've got to figure out how we make better use of a wide transformation and caching and stuff like that. Let's jump back here and take another look at maybe another event that we can see. So data skew. Talk about data skew a little bit. So we've got two clusters here that were running jobs that had data skew. So if we jump in and look at one of those real quick. So we have some SQL that's contributing to data skew here, providing bottleneck for our application, slowing things down. So the first thing we can see here is we have a bad join. So we've highlighted that here. We're getting some nulls in our join that are causing the SQL to run slower. So some suggestions on improving what you're doing there with your SQL with broadcast hints. And then we have data skew. So this data skew, and now we've identified this across multiple areas of our query. So various hash partitioning. So to understand this, again, from your traditional UIs, you don't see this information surfaced easily. You'll see things like, yes, my job is running slow, tasks are running slow, but getting into understanding the data skew and tying that back to where something may be happening in my code, no, not that easy. So we can get something here that's possibly failed and information that we might get on that. So here we have an application that has actually failed. Let's see what we have for analysis. So our efficiency, again, we have some different recommendations that we're bringing here. So idle time in our executors. No tasks are running. We probably have a load imbalance. So this is an idea where we may have skew that's taking place. We see that again here, right? Large variance in work being done. 2 minutes on one executor, 0 on another. Now, one of the things that we can do that I haven't touched on yet is drilling then down into the various layers of our application. So as I've been going through these screens, one of the things you'll notice here, this navigation pane, and this is highlighting all of the jobs that make up my particular application. I can also see this from a Gantt chart. If I want to see over time, this Gantt chart is going to give me a good representation. If I drill down into this, I'll see each stage that related to that job, what they did until we got to our last job here that ultimately then failed. Now I go back and I look at this and I want to drill down into a particular job. So let's go into this first one here that ran these 20 tasks. We're going to see our stage. And if we come down here and we highlight our stage, this is going to let me then see the tasks that executed. So we see the task attempts. I can see the stack in the program that actually was executed for these tasks. So if I want to click this, it's going to take me back to line 41 in my original program, and then I'd be able to see, specifically the code that executed. And then our timeline task here, or tab, is where we can see what's going on as far as shuffling is taking place, or spillage to disk, or from memory. And if you recall, we were in here because we had skewing. And you can very quickly see skewing showing up here with these bar graphs in this histogram. And if I want to see specifically the tasks that were related to that, if I highlight this section, it's going to show me the tasks that were related at that point in time. And I'm going to see which executor and node that was running on. And I can see very clearly this particular task right here is the one that is relating to that skew. There's probably a data imbalance that's going on. So I might want to look at how that's partitioned or how that's being utilized in my application. Now we talk about data. If we come here to the data tab, we can actually look at the DBFS. And if I want to understand what's going on from the DBFS perspective, I can see those KPIs here. what was really important that we like to highlight is going to be table state. And what we do here is allow you to see how much of your data is hot, warm, or cold. Because if you have data that is cold, you may not want to have it sitting out there in the more expensive storage, and we might want to, move that off into a cheaper storage somewhere. Now, if I come over here to the tables tab, this is going to let me drill down further into the specific tables, not just that high level, donut that we were looking at. And if I wanted to look at, again, just specifically my cold tables, which I don't actually have any here right now, I could do that and then quickly identify what I want to move off. But let's go back and look at the hot tables for a second. The information you're going to have here then is understanding, how many applications are accessing particular tables. Well, how partitioned are these tables? That might be something I want to look at. And if I go over here and I look in more info, I can expand this out, and I can also get analysis now on the data side of the house. And I can see that if I have inefficiencies in my data. So in this case, this particular table, we want to have statistics run on this so we can do an analyze table command. That's going to make query execution on this table a lot faster. If I want to see specifically those applications that are accessing that table, I can do that from this perspective. And I can see how much data they are working with. And if I want to look at partition details, I can see that here as well. Now, if I go to, we want to also, when we talk about that holistic context of our clusters and ensuring that resources are not being overutilized by certain users, we have a prevention mechanism that you can put in place. It's auto actions. This is an automated governance process that you can put in place on your cluster. So you can see things like jobs that are running too long, or maybe users that are looking for too many resources when they go to run a job in the cluster. You can put these policies in place that can prevent that from happening and prevent people from blowing up, those static clusters, or having clusters maybe that are just running for too long, eating up too many DBUs, costing too much money, and it was all for a development environment. Those auto actions, they can notify out to a user directly. You could have that post into Slack. But then it's also going to surface right here to this front page that we started at the beginning of this conversation. And I can see all of the various policies that have been triggered. And if I wanted to drill into those and see more detail, I could. Now, I do have a little bit of time. We can talk about chargeback for a second. So we talk about this idea of troubleshooting cost, right? Some people might look at that as part of the performance of their application. If we come here to chargeback, what we can now do is we can look at our clusters. We can see who's spinning them up, and I can, group this cost. I can do it by either user, or I can do it by various workspaces. Right now, let's look at user, and I can see, which users are responsible for most of my clusters. This could be job clusters. They could be my interactive clusters. Who's responsible for using the most DBUs, most of the cost that's allocated to our Databricks usage. And then if I wanted to drill into, say, here, we'll drill into him, and he's running jobs in two different workspaces, the data science and the bank application. And I can see what he's doing in terms of percentage of those two clusters, and specifically what are the jobs that he is running in those clusters. Again, I could drill into each of these individual jobs and see even more specifically what is going on from that level. And if I wanted to break this down, maybe not by clusters, but I wanted to do this cost by job run, then we can do a chargeback based on job run rather than the holistic larger clusters. So you have this capability at your fingertips as well. The last thing that I'll highlight here, a little bit of a fun. We're working on giving you a nice dashboard that'll provide some higher level insights around your cost, your resource efficiency, and what type of acceleration you're getting from your applications, or not getting from your applications based on how many, different types of inefficient events might be occurring. And then you get a couple different top X type reports where I can see things like, my top users from here as far as DBU or cost, etc. So what we've seen here is how we can look at the overall cluster provisioning, how inefficient we may be running our applications across those clusters, drilling in to our various applications and addressing the various events that are surfacing, getting that feedback, the analysis from our AI, freeing up your resident experts that we talked about, being able to understand the data behind the scenes in our DBFS, adding in some governance, those auto actions to help control what's going on in your clusters and making sure that they're running as efficiently as they possibly can. And then this last little fun tidbit that is coming soon is being able to see all of that on a high level dashboard. So with that, jump back over here to presentation, just wrap it all up. So in summary, again, we talked about selecting correct instances for your workloads. There's recommendations around instance types, tuning your Spark jobs for improved performance. If I want to change my memory configuration settings or my number of executors, all different types of recommendations that we can surface with your Spark jobs. And by doing all this, you start realizing your gains with Unravel. You'll realize that faster. We have organizations, and I don't have a slide, unfortunately. I didn't dump one into this presentation, but we have some fairly large organizations making use of Unravel to optimize their Spark applications and seeing upwards of 70% in improved performance. The time, reducing the time it takes to run those jobs, reducing the resources that otherwise were being paid for and sitting idle. As far as trying us out, we have a SaaS offering that you can spin up, connect to your Databricks cluster. You just go and hit the URL that I'm about to pop up here, fill out this form real quick, select Databricks, and then hook it up to your Databricks workspace. And that is the URL, unraveldata.com/SaaS-free-trial. With that, thank you for listening to the presentation, and I'm going to open for any questions that we might have.
Okay, let me see. Thank you. That was great. So one question we have is, does Unravel support Databricks notebooks? Seems like we might be having technical difficulties again. Okay.
Are you able to hear me?
Yeah, I can hear you.
Yeah, it just shut everything down on me again. I apologize.
That's okay. Yeah, so does Unravel support Databricks notebooks?
Yes, so we can work with Databricks notebooks. It's a pretty simple setup that you would just provide. There's a couple settings that you do for executor and driver to include our jar, and not too much more than that, and you're good to go.
Great. Then, do we support Databricks on other cloud providers beyond Azure?
Yes. So Today we support Databricks on Azure, we support Databricks on AWS, and in the very near future, we will be supporting the latest edition of Databricks that has come out on GCP. And I guess one other point I'll make to note on that is you can have all of your Databricks workspaces from across both Azure and AWS. You can have those pulled into a single Unravel instance. So you have access to all of those across the board. You don't have to log into Azure for one, AWS for the other. You just go to Unravel one place.
Thank you.
Mm-hmm.
And the last question I see, is Unravel only available as a SaaS product?
No. SaaS is the real quick and easy way to get started. As I mentioned, you go and you set up your account. We'll give you a configuration page really that just highlights what you need to go and put into your clusters to start having that analyzed. You'll also set up a token that we can use to connect. And then besides that, we have a sort of a full on-prem version. So if there are any sort of data concerns, there are some organizations in the financial or healthcare space that do like to have everything inside their control, inside of their network. So we do have a way where you could then just deploy that onto a VM inside your VPC and then connect to your various Databricks endpoints.
Ooh.
Good question.
Thanks, Patrick.
Thank you.
That's all the questions we have, and that's all we had for this webinar today. But it is available instantly on demand, as we said before, so you can share this with your colleagues, your peers, the same web address as you logged into today. And if you're watching on demand and you have any questions you want to ask us, you can email us at hello@unraveldata.com. And again, you can let us know what you think about the session by rating this webinar and let us know if there's any other topics you'd like to hear about. And again, thank you, Patrick. It's amazing.
Thanks, Sarah.
Thank you for your time, and thank you for everyone watching for your time as well. And we hope to see you at a future webinar. So please keep an eye out for our next optimized webinar, which is on troubleshooting Amazon EMR. So thank you, guys. Thanks again, Patrick.
Thanks, everyone. Bye.
Bye.